Well, we didn't really do. Well, I haven't done. Like, I haven't been to class. Like, since like Wednesday because we had like 2 days off, so I didn't really.
Didn't really what?
Yeah, we didn't really do any. Well, we're last on like properties of like functions and like.
Mm-hmm.
Yeah, that was what we were last on, but we already covered that. So.
Mm-hmm. Properties of polynomial functions, right?
Yep.
All right. So I guess we should move on to the next thing. We covered we covered long division and remainder theorem, did we not?
Yep.
But I don't believe we covered. Did we cover remainder theorem? Yeah.
Yep.
Okay, are you okay with that?
Yep.
But I don't think we covered the factor theorem yet, have we?
I don't think so.
All right, so it's just an extension of the remainder theorem. So factor theorem states that if your remainder is 0, then the divisor must be a factor of the dividend, okay? So if you get 0 in the remainder, then the polynomial of the divisor polynomial, must be a factor of the dividend polynomial. Does that make sense?
Yep.
Okay. For example, 9 is a factor of 18 because 18 divided by 9 is exactly 2, leaving a remainder of 0, right? 36 divided by 12 is exactly 3, leaves a remainder of 0. So that means 12 must be a factor of 36. Do you understand?
Yep.
So therefore, if a divisor is a factor of the dividend, then when you divide a polynomial by that divisor is a factor of that you would get remainder of 0 is what I'm trying to say. So let me say that once again. So if the divisor polynomial is a factor of the dividend polynomial, then when you divide the polynomial in the dividend by the polynomial in the divisor, you get a remainder of 0. All right. So, okay, so let's go on. Let's move to the next slide. And are you okay with these average rates and instantaneous rates now?
Yep.
Yeah?
Yep.
Okay. So let's move on to the next slide. Okay. So let's write down what we just said, the definition. I just have to access my pen. Okay. So factor theorem. So if factor theorem states that if f of a equals 0, then the polynomial f of x is divisible by x minus a. That simply means, in other words, that if f of a equals 0, then x minus a is a factor of the polynomial f of x. Let me write that down as well. So in other words, if f of a equals 0, then x minus a is a factor of the polynomial f of x. Got it?
Yep.
Similarly, if f of b over a equals 0, then ax minus b is a factor of the polynomial f of x. Okay? So that's what the factor theorem is. This is also known as the rational roots theorem. So rational numbers are, remember, a ratio of two integers. A rational number is a ratio of two integers, with the restriction that you cannot obviously have the integer 0 in the denominator, but otherwise the numerator can be 0. So this is also known, called the rational roots theorem. Okay. All right. Any questions so far?
Nope.
All right. So let's take an example. Let's say we have